close to the end of the homework. And it says, for the reaction given here, the following kinetics data is recorded. Graphically determine the rate law and the rate constant by graphing concentration versus time, natural logarithm of concentration versus time, and 1 over concentration versus time. Then we'll use the R squared value, the correlation coefficient, to determine which graph is the best fit to the data, and therefore what is the integrated rate law. Use the slope of this plot to determine the rate constant. And strangely enough, this is a multiple choice question, so your answers are down here, and we just have to figure out which one it is. And fingers crossed, our results will show this. All right, so what I'm going to do is I'm going to share my screen because I'm entering this data into Excel, and I've got my data partially entered in here. Let's see. And for the video, I am trying to line my data up with the video as well as so that you can see it. There we go. I was entering my data in. I'm entering it by hand. You may be able to copy and paste it from the question. There's my data for the concentration of peroxide, H2O2. And then for my data for time, I can see that every single point is 600 seconds more than the previous one. So I'm going to enter in equals 600 plus the number above it and hit enter. And then I'm going to just go over the lower right-hand corner, click and drag, and I've got all my time data done for me without typing it in. Jump in anytime if you have any questions. So now I have to graph concentration versus time, and that's, I've already got that, but I know that I have to do natural logarithm of concentration versus time, so I'm going to type in ln concentration of H2O2, and I'm going to put it in this column. And the way that I calculate that in Excel is I type equals ln, and then I open a parenthesis and do the cell with the concentration in it and hit enter. And now I can go over this lower right-hand corner, click and drag, and now I've got all of the natural logarithms. And you can see the equation for whatever cell you're in up here at the top. The last one I have to do is 1 over concentration. And that's 1 over, and then I'm going to come over here and click on my concentration. And then I can click and drag that down, and then I've got all the data I need. You can do the data one at a time. And but there it is. And so now what I'm going to do is I'm going to go ahead and make the graph. I'm going to click and drag and highlight all of them. And then I'm going to go up to, let's see, insert, chart, and then only points. When I click on that, it'll put all of my points on a chart. And there's different ways to separate these. Let's see. Oop, I think I just accidentally, let's undo that. I just took one of them away. Let's move my chart. Well, and ways that you can do this, you can actually do all three at the same time. If you go and click on this data, it tells me that it is, which one is it? Ah, yes. If I click on the blue dots, it tells me that that's concentration versus time. That's the 0th order plot. I can see it's not very straight. In fact, I can see that the orange dots are the linear one. That's going to be my best answer. But I'm going to do add chart element for the dots, the data that I have highlighted. I'm going to add a trend line. I'm going to go to more trend line options. When I do that, I can go all the way down to the bottom and of this menu right here. And if things were not in my way, I can, there we go. I can go down and display equation, check that box, display r squared value. And I'm going to move this up here so you know that it's for the blue line. I'm going to do the same thing for my gray dots. I'm going to add chart element. I'm going to go to trend line, more options. Go to the bottom, display equation, display r squared. That's the one for right there. And then down here at the bottom, click on the orange spots and do the same thing. Add trend line, more trend line options. The line appears and you want to scroll down to the bottom here, display equation, display r squared. And I'm going to get rid of this menu. I'm going to go over to my chart. And I'm going to look at my r squared values. It looks like my r squared value for the orange dots is the 0.9999, which is better than the other two. And that means, since that's my natural logarithm plot, that means my first order rate law is the one that works. Let's come back and let's see, oh, here's my slope, and it says y equals minus 0.0002. Well, so I'll stop sharing that Excel screen now. And let's look at our data. We made those three graphs. We decided that it's first order, and we decided it's first order based on the fact that the natural logarithm of concentration of peroxide versus time had the highest r squared value. Which means it had the best fit. And then we saw that the slope was minus 0.0002, and that's all that it gave us. And so we can see that that's going to be the 0.00023. Wouldn't it be nice if we could figure out what that, to see that 3 as well? I'm going to share my screen again and give it a run. First off, I'm going to get rid of the rest of this data before I try and do it. So I'm going to click on the blue dots. Let me see, click on the blue dots. I'm going to hit delete, and that data is gone. I'm going to click on the gray dots. I'm going to hit delete. That data is gone, and that clears things up nicely. It still doesn't mean I can see any more significant figures in this. And I cannot drag this anywhere. So let me see if I come back to my data here. And I don't know if this is going to work, but I'll come back to my data. Let me come back to this data and add a few decimal points. Right here, I can add decimal points. No, that's not doing anything. Oh, wow. In fact, it made things much worse. But now let's see if I do the same thing here. No. That changes nothing. All right. So now I'll go to my other trick, which is I'll come down here and I'll type the word slope in here, and I'll use what's called the equal slope function. When you type in equal slope, let's see. So it accepts known y values and known x values. So I'll go here, highlight my known y values, comma, highlight my known x values, close the parenthesis, hit enter or return, and now I have the 0.00023 that is the slope. That's the slope function. You can see it's equals slope, y values, comma, x values, and that gives you that second digit there. And so our answer, final answer for this one right here. Any questions about that? It's an awful lot of work for a multiple choice question.